Hi, and welcome to this AP Environmental Science video. In this video, we're going to be looking at the history of agriculture and modern agricultural techniques. We're going to be studying how we as a society have moved from this image on the left here of prehistoric agriculture and farming to early modern farming, and finally modern industrial agriculture and mechanization of agriculture. Scientists and historians have divided agriculture evolution into three major revolutions, beginning with domestication somewhere between 9 and 11,000 years ago. And the current evidence points to 11 separate centers of origin for agriculture. That is to say that it didn't arise in one particular place or one particular society and spread from there, but really 11 different centers of origin spread across the New World and the Old World independently came about with agriculture. Some of the earliest crops that we domesticated were things such as wheat and barley, lentils, rice, all early crops. And I think it's important to point out as well that this was not an inevitable transition from hunter-gatherers to agriculture, but different cultures adopted agriculture to different extents. And in fact, the evidence suggests that early pastoralists fared worse in terms of their nutrition and their health outcomes than their hunter-gatherer contemporaries. So it's not a smooth journey whatsoever at the beginning, and is a bit of a mystery as to why people began to adopt this style of food production. In the 1600s and progressing through the early 1900s, there's a period of mechanization, which can be described as a second agricultural revolution. And with this mechanization, we saw a shift from subsistence level farming just enough food to feed you and your family, to farming enough crops to sell at the market. And that was a major uptick in the quantity of food that was produced. This coincided with the Industrial Revolution and benefited from, or was made possible by, improved farming techniques and farming tools. It's still important to remember that most farms were small in scale and local in their scope. Beginning in the early 1920s, beginning of the 20th century, there was significantly improved mechanization, fertilization, irrigation, and additional plant varieties. And that allowed for what we call the Green Revolution or the Industrial Agricultural Revolution. And that was a massive uptick in the quantity of food that was produced. All of a sudden, far fewer people were needed to harvest significantly greater quantities of food. And that allowed for a major shift, a demographic shift from farmers to more urban life. And this is what we're seeing continuing today with more people living in cities because they're not needed to farm on the fields. You can see a nice graph here tracking grain production from 1950 to the present day, and just really a steady uptick as more and more industrialization comes about and greater tracts of land are set aside for farming. At this point, I'd like to dig into that green revolution a little bit more and look at some of the factors that allow it to happen. And the first one we're going to look at is this idea of mechanization, which is the introduction of tools and machines to aid us in our ability to farm. And really what this demonstrates is the economy of scale, that the average cost of production falls as output increases. And what that tells us is that if we are farming on larger farms, we can do it more cheaply. We can sell those crops for a greater profit. And I think it's some additional information there. Single crop farms, therefore, become much more profitable. Sorry, I'll zoom out so you can see that. And we need to contrast that, the profit there, with the loss of biodiversity. And with the loss of biodiversity due to the monoculture, there's decreased ecosystem resilience. So we need to balance the health of the ecosystem against the economic benefits of this mechanization and this increased economy. The second factor that allows for the Green Revolution to take place is the introduction of fertilizers. And for much of human history and continuing into today, farmers have used organic fertilizers. Organic fertilizers are composed of organic matter, and that's from plants and animals, things such as manure or crop residue. And those can be spread on their fields, and that will provide much needed nutrients to the soil and to the crops growing in the soil. However, due to the collected nature of the manure or the crop residue, there's a limit to how much fertilizer can be used on a field. So really one of the major impetuses for the Green Revolution was the production of synthetic fertilizer or inorganic fertilizer. And these are fertilizers that are produced commercially, oftentimes with the help of fossil fuels. And what's important to point out here is there's some good chemistry involved, where the Haber process was the industrial conversion of atmospheric nitrogen, combining it with hydrogen gas to produce ammonia gas. And that NH3, that ammonia gas, could then go on to be one of the primary components in ammonium nitrate, which is a fertilizer. So with advances in science and advances in chemistry, we all of a sudden had techniques that allowed us to produce fertilizer on an industrial scale. In addition to fertilizing fields, in addition to the nutrients from fertilizing, crops need water. And the process of irrigation is the movement of water from places where there is perhaps plentiful water to places that need it, where we're trying to grow crops. And when we are irrigating, there's some factors we want to consider. We want to consider the efficiency of the irrigation system, the cost of the irrigation system, and the water use of the irrigation system. And by bringing those ideas together, we have a variety of different techniques that we can use to irrigate our fields. One common one is called flood irrigation. And exactly as the name implies, this floods a field with water. It's cheap, it's easy, it's not efficient. And as we'll see below, it can lead to some major environmental issues. We also can do what's called center pivot irrigation. Pivot irrigation. And this would have a center pivot with a long hose coming out and spigots off of that hose, which will spray water. And the end of that hose is typically on a wheel, which allows it to track in a circle. What you're getting here is more controlled irrigation, more controlled watering of a large circular area. Finally, we have a drip irrigation, which is running a series of hoses through the field with small cuts or small holes placed in those hoses, and water can slowly drip out of the hoses and gradually water a field. This is the most expensive of those techniques, but also the most judicious in terms of water use. So again, a farmer or a group of farmers need to consider the efficiency, the cost, and the overall water supply when choosing how best to irrigate their fields. A couple of the issues that I alluded to earlier. The first is water logging. And if we're using, especially with flood irrigation, if we're leaving water on soil for a long period of time, then water logging occurs when there's degradation in that soil due to water sitting on it for prolonged periods of time. That can damage the nutrients or decrease the nutrients in the soil. We also can have salinization occur. Salinization is the elevation of salt levels in soil. And salinization is a soil degradation that occurs when the small amounts of salts that we get from our irrigation water become concentrated at the soil surface once that water evaporates away. And if you have increased salinity in the soil, increased salinization of the soil, that's detrimental to those crops growing. So you see nice graphics here of this waterlogging of the soil or salinization of the soil. And again, if you fly across the middle of the United States or many agricultural regions, you can see these crop circles being generated by center pivot irrigation. A third method that has allowed the mechanization or the increase in agriculture from the Green Revolution is the increased use of pesticides. And pesticides are substances that can either be natural or they could be synthetic that kill or control organisms that people consider pests. So perhaps there's some beetles that are feeding on the corn or the crop that you're growing. Farmers could spray pesticides, as seen in the pictures below, to kill or to dissuade those beetles from sitting on the crops. There's perhaps a nutritional cost to that with those pesticides remaining on the crops, but there is an increased economic value. Now you're not losing as much of your crops any longer. Related to pesticides, we also have insecticides, which is a form of a pesticide that targets insects and invertebrates that consume crops. Much like a rectangle and a square, you could have insecticide. All insecticides are pesticides, but not necessarily all pesticides are insecticides. We also have an herbicide. An herbicide is something that targets plant species that compete with crops. If we look at the root of this word herb referring to herbal or plant growth, these herbicides can kill weeds that would be competing with our crops. And again, in all of these cases, we need to consider the health consequences, the cost consequences of adding them to the soil against the cost benefits of growing more crops. As we'll see later, there's also some genetically modified organisms that are resistant to certain herbicides, and that leads to an ethical consideration as well at the use of genetically modified organisms in our crops. One more technique that has aided the Green Revolution that I'd like to touch on is the idea of monocropping. If we break down this word into its roots, we see mono or one cropping, one crop. And the idea of monocropping is rather than having a diverse field, a biodiverse field with a variety of crops, but just growing a single crop at a time. And this can be defined as this agricultural method that utilizes large plantings of a single species or a single variety of a crop. There's certainly benefits to this process. This process greatly improves productivity. Large expanses of land can be planted and harvested at the same time. And if fertilizer or pesticide treatments are required, those treatments can also be applied uniformly at the same time. And that is cheap and that's efficient. And there's a lot of value in doing that. But on the flip side, there's some drawbacks, and we can see that monocropping leads to environmental degradation, such as soil erosion. We have a single crop pulling the same nutrients year after year out of the soil. The topsoil contains valuable nutrients, and once they're lost, that reduces the productivity of the land. And monocropping also makes crops more vulnerable to attack by pests. There could be predators who would otherwise have been in the region, in the ecosystem. And if you have a monocrop, those predators no longer have a place to live in the environment and are absent, and that is preventing them from killing off or dissuading the pests that would otherwise be there. So as with the other facets, we need to consider the pros and the cons of monocropping in our choice of what foods to grow and how to grow them. One other advance that has come about relatively recently is genetic engineering. And to speak very briefly about genetic engineering, this is the idea of taking a gene from one organism and inserting it into another organism to modify that gene. We've been modifying species for all of human history. We've domesticated plants and animals, and domesticated wheat or corn looks nothing like the original plants that they came from. Corn, in fact, is a relatively modern invention in the last maybe 8 to 9,000 years. And humans have effectively invented that from a indigenous crop known as teosinte. And that's not what we're doing with genetic engineering. We're not doing a slow, somewhat haphazard, somewhat random breeding process. Rather, we're doing a very targeted change on the genetic level that can be accomplished in a lab. And shown below are two pictures of modern genetically modified foods. On the left, you can see golden rice. This is rice that has been impregnated with a gene to produce vitamin A. Vitamin A is critical in combating blindness. So golden rice is elevated in its nutritional profile and has been used to combat childhood blindness in much of Southeast Asia. On the right, you see a salmon produced by a company called Aquabanti. This salmon, genetically modified salmon, grows incredibly quickly. That allows it to be mature faster, to grow faster, to produce more salmon flesh cheaper and more quickly. Um, and as with all of the considerations that we looked at before, there are certainly benefits and some concerns with genetically modifying organisms. As I've mentioned, there's an increased yield. We can grow that salmon faster. We can actually grow rice faster. We have crops that are resistant to certain diseases, resistant to frosts. We also have increased profit. If you can increase your yield, you can typically increase your profit. And those things, we could argue are valuable. Balancing that out, there's concerns. There's concerns about the safety for consumption. And at this point, there's no research pointing to any dangers from genetically modified foods, but research is only as good as the evidence we have. And we are gathering more evidence all the time. But again, it's important to remember there is no evidence yet of any dangers of consuming genetically modified foods. There are valid concerns about the effects on biodiversity. And if we are growing a single strain of genetically modified crops, that is going to displace or outcompete non-genetically modified crops, and that is going to change an ecosystem. It's absolutely a valid concern. And then there's really lacks oversight or a lack of regulation. And again, there's not any dangers yet that we've found with genetically modified organisms, but there's questions about the economics of it and which companies own the patents, how they're selling the seeds to farmers, what sorts of pesticides or herbicides are being used. And in a developing market here, there's not very good oversight or regulation there. That said, there are several standards that have been put in place. In the United States, the National Bioengineered Food Disclosure Standard of 2016 was put in place, and the U.S. Department of Agriculture has required some labeling as of 2022. So there are some labeling efforts in this country. We can contrast that where in the European Union, nearly all genetically modified organisms are banned. It is quite the contrast to what's going on in the United States. The final topic I'd like to look at in this video is the idea of energy subsidies. And what we're looking at here, the big idea is that mechanization provides increased yield and efficiency, but also increased energy use. And this is what I want us to focus on in the last minute or two of this video, is the idea that yes, this green revolution has brought about tremendous amounts of food, allowing us to feed a population of over 8 billion people on this planet, but at a cost of significantly increased energy usage. And if we look at where that energy usage is coming from, on large mechanized farms, we have to do a huge amount of planting, growing, fertilizing, irrigating, and harvesting of that food. That all costs energy, which typically comes from fossil fuels. Off the farm or later in the process, we need to process our food. We need to prepare our food. We need to transport our food. And that again costs a lot of energy coming in the form of burning fossil fuels. We can classify all these as energy subsidies, which we call the fossil fuel energy and the human energy input per calorie of food produced. That is to say, if you want to grow 1,000 calories of food, how much energy do you need to invest across the entire lifespan of that food to get that to happen? We can look at some example, relatively small energy subsidy. It was mostly human powered, it was local, it was small scale. We weren't using genetically modified seeds, we weren't transporting. It was a relatively low subsidy. By contrast, the average modern US diet, which contains foods mostly produced by modern agricultural methods, is estimated to have about a 10-calorie energy input for every calorie that's eaten. So if your average diet, the average American diet is, we'll call it 2,000 calories a day, that requires about 20,000 calories of energy input. And again, most of that is coming in the form of burning fossil fuels to generate that energy. So again, just a bit more detail about where's that energy used. Most of the energy subsidies in modern agriculture are in the form of fossil fuels, which are used to produce fertilizers and pesticides, used to operate tractors, used to pump water for irrigation, used to harvest food and prepare it for transportation. Um, Again, a lot of that is transportation, accounts for about 10% of energy subsidies. And interestingly, the average food travels about 2,000 kilometers. That's 2,000 kilometers from where it is grown to where it is eaten. That's from the farm to the table. Finally, the US Department of Energy reports that in the United States, around 17% of total commercial energy use goes into growing, processing, transporting, and cooking food. And that is a tremendous amount of energy there. I want to show a final graphic down below here, looking at energy subsidies for a variety of foods and diets. What you can see at the bottom is that hunting and gathering requires a very tiny energy subsidy. Eating low on the trophic level, eating vegetables, relatively low energy subsidy. As we move up on the trophic scale, begin to eat some animal products, that's requiring more. And you can see the US diet has about doubled in its energy subsidy in the last 60 years or so. And that's something that we need to consider as a society. So I appreciate you listening and watching this video, and I hope that at the end of it, you're able to do these 5 tasks. I hope you're able to describe changes in agricultural practices that have occurred throughout human history. I hope that you can explain changes that developed as a result of the Green Revolution. I hope you can identify the benefits and consequences of innovations during the Green Revolution, that you can identify specific benefits and consequences of GMOs, and finally, that you can describe the resulting efficiency and fossil fuel impact